coding competition site, you can log into it, and then challenge a person to a coding competition. You write code on your screen, and the other player will write code on their screen, and the first person to submit the first code wins. So it's pretty simple. But it turned out to not be so simple when you're yeah. So that was a lot of fun. We used a lot of different technologies with this. The whole website is done in Rails. We use, I'm just going to write them down real quick, deploy. We use Capistrano. On the server, we actually use Passenger instead of the built-in Rails server. I think it's like WebBrick. We use MySQL for the database. We actually, instead of deploying to Heroku, we deploy to Amazon EC2 because of some limitations in Heroku. For instance, we couldn't execute arbitrary code on a Heroku instance. We use Git for version control, of course. There were a lot of gems we used for user management. We just used Devise. We didn't try to write our own because that would just take way too much time. We wanted to focus on things that were more fun. We used CanCan for permission control. We used for the front end, we used a bunch of different tools. We used HighCharts for the LiveGraph page, which I'll show you guys when I demo it. We used Ace as a text editor because you're going to be writing code in the browser. We use Best in Place in a few places. We'll actually get some profile. It looks pretty cool. And then we use Graptastic to manage user icons, so it just pulls your Gravatar. Yeah, so it'll just load up whatever thing you have on your Gravatar thing there. Yeah. I don't know if you guys will read that. For the architecture, the models were actually pretty simple that we designed. There's only 3. Besides, we added forums, but that was all managed entirely with one single gem. We just included that gem, and it pretty much solved everything for us. So there's games, there's users, and then there's problems. And one game will have a problem. And in the problem, there's a class, a main class, that the problem creator writes, and that's responsible for checking the code that people write. And then there's a template class that will be shown on the page that people compete on. So instead of writing a whole Java program, there's a little thing that you can fill in that'll start you out. So that's the basic architecture. I'll show you guys a little walkthrough of the game. So I'm here on one page. I'm already logged in. I'm going to hit play on this page. Hit play over here. So here's the live graph. The way it works, the x-axis is the time limit. The y-axis is your rating. We actually use GLO for the rating. It is pretty simple, and it works pretty well. So let's say you want to make a 20-minute game. You do that. You hit create. Tells you your game is been created. It's a 20-minute game, and my ELO of between 1,000 and 2,000 right now, so it gets stuck right there. So the other player will look at the graph and they'll see that little dot, they'll click on it, it'll be sent to the game page. And see, both players are actually sent to the game page at the same time. We'll talk about that in a second. You see here on this page, you've been given this challenge to write a function that returns an array of numbers from 1 to n. So I'm going to do that right now real quick. probably a better way to do this, but this works. You guys want to criticize my code a little bit? So, I take a pleasure in criticizing. Go ahead. So here, I've written this function that should theoretically create a Newton-Innes array, fill it with numbers 1 and number 2. I can check it real quick and see if it gives me any errors. Compile it. No errors. Someone hit submit and see if it actually is what the problem asked me to do. That's how it works. And it works. I won. And actually on this page, the other player immediately sees that they lost because the other player submitted working code. So that's that. You can hit play another game. Play another game. So that's the website. It's pretty simple, but like I said, it was really hard to implement. Some of the challenges that we had, in my opinion, the hardest part was getting both players to join the game at the same time. That's a good question. So there's two ways that we could have done that. One way, what you can do is you can just make like a status page for a certain game, and if the game is currently open, it'll give you a certain JSON response. And if somebody has joined the game, it'll give you a response that says that somebody has joined the game, and then you can periodically refresh that page and see if someone's joined. And that's the bad solution, because if a lot of people are playing on your website, you're going to be wasting a lot of bandwidth just periodically pulling the page over and over and over again. So the better solution is to open a socket or a TCP stream from the client to the server, and then keep it open for as long as you can. And then once somebody joins the game, the server will send a message to the client telling the player that somebody has joined the game, and then the player will go to the game page. We did it the bad way because we wanted to launch the website in time for that demo. But if we had more time, we would have done it the second way.
It's a common story.
Yeah, but it works for now. The other biggest problem was getting the code execution to actually work correctly. That was kind of tricky. We had to, there were a lot of little intricacies that popped up in there. For one, there's the problem of you can't possibly know if somebody's code is ever going to stop just by looking at the code. You know, it's the halting problem. There's no way to possibly prove that code is correct. So what we did is we just stuck a time limit on the code. If code goes over that time limit, we kill it, and the player loses if they submit it. Another problem that dealt with synchronous information between the client and the server was the time limit for the games. Because if the time limit expires on the client, how does the server know that the time limit has expired? What we actually did is that if the player, it's kind of a, I don't want to say hack, but it works. If the client tries to submit code past the time limit, the server will find out that the time limit has expired, and it'll reject that code, and it'll complain to the player that the time limit is up. Yeah, so that's how we keep track of games time limits. Yeah. That's about it for the challenges. I mean, getting deployment set up with Amazon wasn't that easy because the library, the tool we were using, Capistrano, was kind of in development, and it took a lot of reading the website and looking at what other people were saying and looking at the actual source code of the program because nobody actually documented everything. Yeah. Does anyone have any questions?
What's the y-axis?
That's your rating. So there's like an ELO rating, like what you would use in chess, or actually
Like skill level?
yeah, or like I don't know, StarCraft. You're rating in that. And so if you have like a certain rating, you can try to look for people with a similar rating to see.
But can you choose your own rating?
No, you can't. It's calculated. There's a mathematical formula that we use.
Is the player given any indication of what the other player's progress is?
No, that's something that I would like to add. Being able to see what the other player codes probably wouldn't be a good idea, but maybe just seeing if they're compiling. If that's,
We didn't have time to do screen sharing.
Also, when the game's over and you lose, let's say, can you
Yeah.
still continue to play and check your code?
no, you can't, but there is a practice feature of the webpage, so if you want to practice on a problem that you failed on, you can go to that page and try that. Yes.
How are you verifying that submitted code is actually correct?
That's part of the person who writes the problem's responsibility. There's actually, whoever writes the problem has to write Java code that will compare the output of the user's written function and compare it to what the actual output is supposed to be. So we don't do that. As long as the program returns a certain response code, then we'll just assume that it's correct.
So Java.
We could add other languages. It would actually be pretty easy because you would just change the Java command in the source to Python or whatever you want to. Yeah.
So hypothetically, someone could hard code the correct answer somehow when they compile.
In some cases, in this case, you couldn't because the array will be an arbitrary size. There's a big problem where people who are playing this game are probably going to be very creative, and they're probably going to try to figure out ways to break the system that we've made. So if we do ever deploy this, we're going to have to spend a lot of time working on security.
Yeah, how are you checking that, like, say, like, I'm a player, it's like, what's stopping me from saying, like, having a bunch of code, copy, cut, paste it onto there and say submit?
Oh, what, like if they already had to
Yeah,
play the problem and
yeah, they
pasted it?
receive it and like, okay, copy, cut, paste, I win.
I read a lot of problems. What'd you say? We could do that. Yeah.
The question is like, how are you preventing users to execute bad code? Let's say we talk about.
That's another thing that we're working on that too. We're trying to work on sandboxing the user. We've thought of that. For the demo, I mean, I'm not going to try to write malicious code while I'm up here, but so we didn't really work on that. But if we do deploy it, that is going to be like the main focus that we work on.
And the first step we did was separating the main class from the template class. So you can't write, you don't have access to the main and do anything in there. So that's one step that helps to prevent that kind of thing. But yeah, ultimately we'll sandbox what they send into a different thing, and then they can do whatever. And if it's malicious, then we don't care.
Let's take the remainder of the questions offline. I want to get through 3 more.